computer language is a mathematical language that, like the binary language, 1, 0, 0, 0, 1. And doesn't have any potential for understanding human language. And so that's where natural language processing enters in the game. If you think about it, personal computers and powerful computers are in the market since more than 50 years, 70 years. But still, until recently, they couldn't actually understand texts. What natural language processing is trying to do is to give them the ability to understand language. And this ability is given by some very interesting findings that were actually findings in linguistics also. Just to give you an idea, the semantics of a word, so the meaning of a word, is understood by looking at the contexts in which this word occurs. To give you an example, the word dog is likely to occur with bark, and is likely to occur also with sleeps and run. So the word of cat is likely to occur with run and sleep. So somehow, the word of cat and the word of dog are similar because they occur in similar contexts. And so starting from such a simple assumption, we can create these vector representations that help us to understand similarity between words, and that they help to understand also similarity between sentences and so on. And this is the concept that I try to explain in my talk. There are two principal issues in AI. One is representation, and one is similarity. And this is at the core of natural language processing and the field of AI that deals with human language. So it's a new field. Natural language processing has started since a few decades. Before, people used to use rules, so write patterns to identify some pieces of texts. Nowadays, we don't write patterns anymore. There are machines that can learn these patterns by themselves. Given, of course, annotated data. This progress has happened in 10, 20 years as maximum. So if you see what we can do nowadays, when you Google something, you have answers to your questions. When you speak to Alexa, when you speak to Siri, you can have some important information. Of course, there are limits. We know there are some big limitations in these algorithms so far. But if we look at the past years, these limitations were much more than they are today. So I can see that in the next years, this limitation will be somehow surpassed, will be somehow addressed by the researchers, and I guess NLP will help the industry in performing a lot of tasks that currently are performed by humans in a much slower way. So humans, today during my presentation I said, humans are an outdated technology. And by this I meant that humans are slow because we work in a kind of sequential way, and machines can work in non-sequential ways. So if we manage to use machines to perform those tasks that are repetitive, then we can actually save a lot of time. And that's where machine learning can help in the industry. Let me also say that if we help the industry with machine learning in this respect, we are going actually to ask humans to do much smarter tasks, which is where humans can actually excel. We are smarter than machines, and we should use our intelligence for smarter tasks rather than for these repetitive tasks. Natural language processing can be applied to other domains and other companies. What we do in my lab, mostly with Regina and all my other colleagues, is to extract information. And every company needs to extract information because if you look at the amount of data that we produce daily, this amount is increasing in a very exponential way, while our ability to take advantage of this information is growing in a linear way. So you see a curve that is going up like that, and you see our ability that is going up like that. And of course there is a gap, and we have to fill this gap. If we keep using human beings in extracting information, we cannot grow more than linearly. And that's the limitation currently. If we use NLP, we can somehow replicate the curve of the data growth. On top of healthcare, we can work, for example, on pharma. Pharma needs to monitor a lot of information. In particular, they need to monitor the post-marketing process. When they put some drugs on the market, they need to verify and make sure that these drugs don't harm people. And to do that, they have to check all these reports that doctors create about adverse case events. And these reports are over 1 million every year. And it's impossible to ask humans to do this kind of monitoring alone. So machines can help in that. Other fields are, of course, marketing, social media monitoring, and so on. There are many ways in which artificial intelligence can contribute to the business world. I speak from the natural language processing perspective. Every industry, as I said, every industry produces a lot of data and needs to monitor a lot of data. So that's where you want to use natural language processing to help you to monitor this data. This is one of the possibilities. Other possibilities are in journalism. Journalism, nowadays we are obsessed somehow with this fake news, which, let me say, is not a new event. They are now, there is a hype on the fake news, but actually it's something very old. In the Roman Empire, there were already fake news. But the fake news is still a real problem because it's affecting our democracies, it's affecting our beliefs, it's affecting many things on our society. So we want to deal with them. We want to try to discover which news are trustable and which news are not. Systems of natural language processing can help in this process. They can, given a news, for example, they can segment the news in claims, and for every claim they can try to search for evidence for these claims. And given the evidence, they can say whether this evidence is supporting the claim or is refuting the claim. And at that point, you can say whether the news is reliable or not. This is another application that can be done. But there are a big number. Another thing that Adam Yala is doing recently is predicting cancer with 5 years in advance to the actual diagnosis, which is a very, very important task because it can save lives. Currently, his system obtains an accuracy of about 72%. So with an accuracy of 72%, the system can predict whether a woman will have or not breast cancer in the next 5 years.